All right, draw a Born-Haber cycle for rubidium iodide. Okay, and hence use the data below to calculate the enthalpy change of formation. So all five of them come out, right? See, formation 1, atomization 2, lattice energy 3, ionization 4, electron affinity 5. Everyone okay? Standard 5. All right, so all values you have already. So let's move it up. I want the whole space for myself. Okay, so what do? Let's do this. All right, we're going to draw a vertical line as long as you can with the space available. Energy, kilojoules per mole. Follow me very closely. And along the way, which usually we say near the bottom, but not the bottom, leave some space, right? 2 cm, for example, we usually say it's 3/4 or 4/5, right? That's where you draw your, what we call the point zero, the elemental state, that one, to form your ionic solid. Okay? So what do we want to make? You want rubidium iodide, right? So do a side map. Ask yourself what you need. Obviously, I need rubidium, the metal, which is obviously solid. I need iodine. Anyone? Iodine is in what state? Iodine is a gaseous. Wrong. I take that. When did we learn this? Sec 3, Sec 4 periodic table group trends. Fluorine is a gas. Fluorine is a gas. Bromine is a liquid. Iodine, astatine is solid. Are solids. Everyone okay? So these are the part that I can help you. Have to recap. Forgot, write it down somewhere. Okay? Now, then we all know it must form rubidium iodide, right? So formation, remember? Formation. I can write the formation line first. Now, the thing is here, is the line going to be higher or lower? This question is considered difficult. Usually, it's easy when they give me whether it's higher or lower. Are you me? Because formation depends, remember? Can be endo, can be exo. Can you see that? Got no definition to help you. Can you see? It's all about the one mole and whether endo, exo, or depends. It depends. So I don't know. Then I say I don't draw first. If it's given to me and they ask me to calculate other information, the other delta H, then it's easier. This question not as easy. Then what? Then I say never mind lah. Use other information to give you. So here we go. First one, you know, I'm going to convert that out like the flowchart I told you, right? So I'm going to do atomization of rubidium, which I have a value was 86. All right, so I get it up here. Very easy, right? So rubidium, make it a gas. Don't be ambitious. Do one at a time. The non-metal don't touch first. After that, then you touch the non-metal. I want to get them into gaseous atom first. So here we go. All right, now I will do this. This is atomization enthalpy of iodine, which the value is plus 107. And I would like to do a side map because the side map will confirm our answer. All right. So using green, I think the rubidium is quite straightforward. Everyone okay? Okay, never I write it out. This is basically rubidium solid to rubidium gas. This is called atomization enthalpy of rubidium. Everyone okay? One more of this. Iodine, what is called atomization enthalpy of your iodine? Is 1 mole of iodine gaseous atom that's produced from its constituent element, which is a diatomic molecule in the solid state. And you times half, it looks like this. And then from that, you realize we did not include something. So along the way, you have to change it. What we didn't do? We did not write out the formation enthalpy of rubidium just now as a side map. Do you realize that? Because if you are looking for formation, you will then be able to balance this part very nicely. It's half. We forget to put the half in. Do you realize that? Understand, everyone? So this is formation enthalpy, right? Or rubidium iodide. Can everyone? If you put a half, you're okay, huh? The equation must have half. So if you half, then now it makes sense. Can you see? The blue color, take a look. Half I2 solid, atomize it, give me 1 iodine gaseous atom by definition. Okay? So we have our gaseous atom. So what are we doing? Let's get the ions out. Again, don't be ambitious, one at a time. So here we go. Let's get our 1 plus ion out. All right, so here we go. We squeeze it here. And this one, normally I'll go very long. Why? You should, right? Again, not long later, you join up, doesn't matter. So I'm going to do first ionization energy. And people always miss out this one. Must win the what? The electron. It must be there that later combined with my iodine atom. All right, so what is this known as? This is called first ionization energy of your rubidium. And the value was given to us plus 402. This one, I don't need to write side map. I think it's quite straight to the point. Okay? So if you're happy with that, then I cancel off, remove the side map already, which is not meant to be here, by the way. Then what do? You then have to write the EA, which is the iodine take the electrons. This is a point where, because there is a reference long line on top, right? They will want to see whether this arrow is short or long, and they try to find fault. Right? So it is like that, or like that. Right? I believe it is shorter in terms of the arrow. Why? Because the first electron affinity of iodine value is given to me is minus 314. If I compare magnitude 314 and magnitude 402, regardless of the sign, it tells me the arrow must be shorter. Are you with me, everyone? Make sense? And that's what they do, right? Because there's a common line. So they're going to find fault. So make sure that one's correct. Okay. Then you have rubidium plus Ni minus both in gaseous state. So remember 5 enthalpy, different enthalpy, right? One have we played? We have played atomization, ionization energy, electron affinity. Left with last 2. Formation, which we can't squeeze in until later, and lattice energy. Make sense? So we know the next one must be 2 ions, and then they do lattice energy, delta H lattice, right? Which is rubidium iodide, which they give me the value. What's the value? Minus 609. Make sense? So I have used 4 out of the 5 that we need. Make sense? And the last one, I want to close it, which I don't know. Where is it? Where is the black line? Now can do already. Pause. Ladies and gentlemen, if you look at it, left and right hand side, they all have the same ceiling. Can you see? We are doing primary one common sense. You see what I'm going to do? Over here on the left side, 400, 100, close to 100 is about how much? What is this value? Did I miss out anything? This is about how much? Say 600. Am I okay? Take a look, and on the other side, 300, 600. How many hundred? 900. And I'm going to have one last line to balance them out. Are you with me? So now, do you agree with me? Or what do you think? The line, do you think is higher like this? Or can't be the same line as the original 0? It must be lower. So higher or lower? That's the question. Are you with me? Obviously, to balance out, it must be lower. Make sense? To balance out the both sides. Done. That's it. This lattice energy is the magnitude. Right? Such that now I know what is my formation enthalpy, which is here. I mean the arrow, join up or down, I know already. I know it must be exothermic. Close it. This is RbCl solid 1 mole. Don't touch. And this is the value they're asking me. And let's close the question. Okay, everyone? Make sense? So again, we're going to do this thing called by Hess law, right? So by Hess law, you need to do your vector summation rate. Right? By Hess law, so what? It's about anti-clockwise movement. In this case, it's called delta H, equals to clockwise, delta H. Okay? So again, where is the clockwise and anti-clockwise? It's choosing the pivot point. Understand? So how to choose the pivot point? What did we say just now? Go for the elemental line here. Yes, along that line, find that point whereby it starts to have 2 different arrow directions. So where's my pivot point? This is the pivot point, which is poorly discussed in school over the years. People always tell me, my teacher said, I wrote up, I wrote down. I said, I'm very sure they never say that. Can't be so boo-boo. You are the one who said that because you made the mistake. It is not. It's called clockwise movements, anti-clockwise movement. Am I okay? Are you with me? So you can check it out, right? So basically what I'm going to do is this, right? So if I use color, right? So what is the anti-clockwise? I think there's only one here, right? So anti-clockwise versus the clockwise. Clockwise got a lot, right? So let's finish up. The clockwise, I use brown, right? Am I okay? If you have a calculator, you can shoot. And this is don't need to manipulate, straight to the point. Therefore, delta HF theta RBCL is equals to, you sum all the brown color together. Wait, sorry. Oh, rubidium iodide. Okay, I make too excited. Iodide, chloride. Thank you, iodide. No, these are also wrong. Yeah, this is iodide. My apology. Southern plate iodine. All right, check it out. Using the brown color arrow add together, positive, negative, all the sign, take care of it. Did you manage to get the one that's listed there? -328. F, we are good to go. Yes? Okay, Julie can get? Check out. Thank you very much. Done. Am I okay? Check it out. So very important is to choose that line. Am I okay? And even more important is the ability to sort out every arrow with your fundamentals, which is basic concepts, part 1 set of tricks.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.